All right, this is lesson 3.3, systems of inequalities. So still dealing with systems, but now with inequalities instead of equations. And you're going to have a lot of solutions with this, not just one solution or infinitely many or no solutions anymore. Now you'll have like a plethora of options whenever you have an inequality, right? Those are inequalities. So when graphing, you graph what's called the boundary line, but then you're going to shade with it. So we'll talk about shading in a minute, but as far as getting your boundary line, whenever it is less than or greater than, in other words, we're not having the equal to bar underneath it, that's going to be a dotted line. In other words, we don't include that line. It's less than that line. It doesn't equal that line. If it is a solid line, that's when it's going to have the less than or equal to or greater than or equal to. So you just need to really pay attention to that. I think this is the thing that people forget about the most because they're just so used to graphing a line. So everything's solid. Don't forget that sometimes you're going to be putting a dotted line in. Okay. And then the second thing is you need to decide which side of your line you're going to shade on. And to do that, we plug in a point. Now, typically I say plug in 0, 0, but if 0, 0 falls on your line, then you have to pick a different point. Pick 1, 0 or negative 1, 0, something else to plug in. When you plug in your point, if it's true, okay, so maybe you want to make a little note of this. If true, I don't know what that is. Let's try that again. If true, that's a U. You're going to shade. So let's say we're plugging in 0, 0. Okay. If it's true, you're going to shade the 0, 0 side of your line. If it's false, you're going to shade the other side of the line. Okay. And that'll make more sense when I actually do it for you, which we're going to do right now. So this first example, it says graph the inequality. Now, I want you to first think about graphing this as if it's just a line with an equation. Here's what I mean by that. If this is my inequality, you're essentially going to graph the line y equals 2x minus 3, okay? So treat it like an equal sign initially. This we'll change it with what we actually do with it, but think line, okay? So if I'm graphing this, this is a y-intercept of negative 3, 1, 2, 3. And then it's a slope of 2, okay? So your slope is going to be 2 over 1. So you're going up 2 over 1, up 2 over 1, and so on and so forth, okay? Now here's where you need to stop and think. This is less than. It's not less than or equal to. So this is going to be a dotted line. So you're going to line it up like this. Dotted line here. Okay. And now we need to shade because it's an inequality. It's saying it's everything less than this. Well, if I pick the point 0, 0, okay, if I plug 0, 0 in to this, so I'm going to put a 0 here and a 0 here, right? I'm just plugging in the point 0, 0 into my equation. It would say 0 is less than 2 times 0 minus 3, which is 0 is less than 0 minus 3. So basically it's saying 0 is less than negative 3. And you have to ask yourself, is that true? That is not true, right? 0 is not less than a negative number. So when it's not true, you don't want to graph 0, 0 as part of your answer. So we're going to shade, instead of shading this side of our graph, we're going to shade away from the 0, 0. We're going to shade this side. Okay. And I always do just a bunch of parallel lines like this when I shade. I'll show you why in a little bit. It'll make more sense. You don't have to do it this way. If you want to shade it just squiggles like this, that's totally fine. I'll show you in a little bit why I think my way makes a lot of sense to do it like this. Okay, so that's our first graph. Second graph, now you can do the cover-up method still with these. Again, we're going to kind of treat it like an equation. So if we do cover-up method, we would say 4x equals 4 would be one equation, and 2y equals 4 would be the other. And then divide by 4, we get x equals 1. Divide by 2, we get y equals 2. Okay, so if x equals 1, that's my x-intercept. Y equals 2, that's my y-intercept. Now take a look at your symbol. It's less than or equal to. So this is going to be a solid line. So I'm going to line up my straight edge, draw that solid line in. Okay, and now I want to plug in 0, 0. So this point right here, I'm going to plug that in to check if it makes my equation true. So if I go 4 times 0 plus 2 times 0 is less than or equal to 4. Well, this gets me 0 plus 0. So I get 0 is less than or equal to 4. That is true, right? That means I want to shade the 0, 0 side. If 0, 0 is part of my solution, I want to shade that side. So I'm going to shade all of this. Okay, that means anywhere to the left of that line is a solution to that inequality. Okay. Okay, this one, x is greater than 5. Again, think of this like an equation. If I graph x equals 5, that is a vertical line at 5. So 1, 2, 3, 4, 5. I'm going to put a vertical line. Now notice there's no bar underneath, so this is a dotted line. Okay, and if I plug in 0, 0, if I plug in 0 here, 0 is greater than 5. That is not true. So I want to shade away from 0. So basically I'm shading this whole side of my graph. Okay. Okay, now they get a little fancier. Remember absolute value. You should have a V-shaped graph for absolute value. So we're going to start by figuring out what our vertex would be. Remember, the vertex is opposite of what it looks like inside and the same as what it looks like outside. So it looks like a -2 right now. That means it's a +2. And then it looks like a -5, so it's going to be -5. So first thing we're going to do is we're going to plot that vertex. So 2, -5. That's this point right here. Okay. And then if you remember, there is no number in front here, so we treat that like a 1 out in front. So this is a V shape, and it's up 1 over 1. But you got to go both ways, up 1 over 1. Okay, so you could just keep going. Ask yourself, is this a solid or dotted line? That is determined by this guy, right? Less than or equal to is going to be a solid line. So we're going to take a straight edge here and draw this line in and draw this line in. Okay, and now again, 0, 0, right here, we can plug that in to see if it's going to make our equation true. So if I plug 0, 0 in, I get 0 is less than or equal to the absolute value of 0 minus 2 minus 5. So I get 0 is less than or equal to, the absolute value of -2 is 2. So it's 2 minus 5. So 0 is less than or equal to -3. That is not true, okay? Because that is not true, we're going to shade away from 0, 0. So 0, 0 is up here. We're going to shade away from that. So we're going to shade down below this line. So the line is just acting as our barrier. Do we shade above it? Do we shade below it? Do we shade to the left, to the right? Depending on how the line is set up, you'll be able to figure that out. Okay. Okay, this next one, is a little trickier yet, just because of one thing that you need to do. So notice it's saying a negative y out in front. Well, we don't want a negative y. We want our equation to say y equals or y is greater than or equal to here. So we're going to divide. Actually, you know what? It would make more sense if you think of this as multiplying by -1. Because when I multiply by -1 here, I end up with y. So then I'm going to multiply by -1 on this side too. And here's where you have to be careful. With inequalities, what happens when you multiply or divide by a negative? You flip it, right? So we're going to flip this over. And now it's going to be a -1 times the absolute value of x plus 1. Okay, so now we can come up with the vertex. Our vertex is going to be the opposite of what's inside, so -1, and then the same as what's outside, but outside there's nothing, so that's going to be 0. Okay, so I have a vertex at -1, 0, right here. We know this is going to be V-shaped because of the absolute value bars, and then we know our slope. Our slope is -1, so that means I'm going down 1 over 1, and the other way as well, down 1 over 1. Okay, so I can take this, draw those lines in, and I get my V. This is a solid line, right? It's solid because we have the bar underneath. Okay, so it looks like this. And now pick a point. And again, I would plug in 0, 0. So if I plug 0, 0 into my original equation, just plug it into the original, you have a -0 is greater than or equal to the absolute value of 0 plus 1. Well, -0 is 0. So is it true that 0 is greater than or equal to absolute value of 1 is 1? 0 is not greater than 1 or equal to 1. So we don't want to shade the 0, 0 side. Okay, what we plugged in, we don't want to shade that side because it's not true. So we don't want to shade by 0, 0. We want to shade away from 0, 0, which would be this side. So that would be our graph. Okay. Okay. Now they get a little fancier yet. Now we have solving systems with inequalities. So we're looking for overlap here. We're looking where things match up. Okay. So for this one, we are going to graph two equations. Okay. This first one, if I say 2x equals -3, Coverup method, okay, and -y equals -3, then I can, you could do it this way. Yeah, whatever. We'll do it this way. It's just not beautiful, but it's okay. X equals -1.5 and divide by -1, y equals 3. Okay, so one of our equations here, inequalities here, excuse me, we get x is -1.5, so that's here. Y is 3, 1, 2, 3. Okay, this is going to be a solid line. So you would take your straight edge and draw that line in. Okay, now plug 0, 0 into that. 2 times 0 minus 0 is greater than or equal to -3. Well, that's 0 minus 0. So 0, is it true that 0 is greater than or equal to -3? That is true. So you are going to shade the 0, 0 side, right? If this is true, then you shade where 0, 0 falls, and 0, 0 falls here. And here's where I like to do all my lines perpendicular to the line that I'm working from. And you'll see why on this next one. Now I'm going to graph this. Well, that's a y-intercept of 1. So I go up 1. And then a slope of -1/2. So down 1 over 2. Down 1, oops, that's over 1. Down 1 over 2. Down 1 over 2. So we get this line. Again, it's a solid line because it's got the equal to bar underneath it. And we draw that line in. Okay, and again, plug in 0, 0. 0 is greater than or equal to negative 1/2 times 0 plus 1. Well, this is 0 plus 1, so it's saying 0 is greater than or equal to 1. Not true, okay? When it's not true, we want to shade away from 0, 0. So we would shade up here. Okay, and the whole idea is you are looking for where did they overlap. And if you look at my graph, there's lines going this way here, and then lines going the other way here. Okay, that's my overlap, and I need to see that from you. So once you figure out where your overlap is, just make it really dark, because that's your answer. Your answer is where do those overlap? That would be it. Okay, letter B. I would do Coverup here. So x equals 6 and negative 2y equals 6. Divide by negative 2. So y equals negative 3. Okay, so we're going to plot that. X equals 6. 1, 2, 3, 4, 5, 6 is this point. Y equals negative 3 is here. Notice this is going to be a dotted line because it's less than. Okay, so we're going to go dotted line here. And then switch to our red line. So this one, when we graph it, this is going to be a solid line. And our y-intercept is 5. 1, 2, 3, 4, 5 right here. With a slope of negative 3/2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Like I said, solid line. I'm going to just freehand this one for now. Okay, and then we want to shade where both of these would be true. So we're going to plug 0, 0 into this. You can shade right away if you want. I just sometimes think the overlap gets a little hairy. But if I plug 0, 0 in, it would be 0 minus 2 times 0 is less than 6. So 0 minus 0, basically 0 is less than 6. That is true. So we're going to graph the 0, 0 side on our black line. So we're going to graph this. Okay, that's our shading. For the second line, our second line, if we plug in 0, 0, it would be 0 is less than or equal to negative 3/2 times 0 plus 5. So 0 is less than or equal to 0 plus 5. That is true. Okay, so again, we want to shade the 0, 0 side. So that would go this way because 0, 0 is right here, right? So we're going to shade the 0, 0 side because it was true. And you notice your overlap is where it makes those boxes, which is all of that. Okay. All right. Next one. This first one is very simple to graph. Y is less than or equal to 3. So you graph y equals 3. It's a solid line because it's got the bar. And it's saying y is less than. So if I plug in 0, 0, basically I'm saying 0 is less than or equal to 3. That is true. So I want to shade down below for my black line, which I turned into a green line, sorry. This one, absolute value bars, means that we have a V. So what you're doing here is you find your vertex. Okay, my vertex would be the opposite of what it looks like. So 1, and then there's nothing here, plus 0. So 1, 0 is my vertex. That goes here. My slope is 1, so up 1 over 1, up 1 over 1. Okay, this again is a solid line because it has the equal to. So it looks like that. Now if I plug in 0, 0, right, here's my equation. If I plug in 0 is greater than or equal to the absolute value of 0 minus 1, that's saying 0 is greater than or equal to, the absolute value of negative 1 is 1, and 0 is not greater than or equal to 1. So that is not true, which means for that one, we're shading up above. Okay, so we're looking for the overlap of those two, and the only place they overlap is in this little triangle right here, where we have double shading. Okay. All right, last one. You have y is less than or equal to x plus 3. So you're going to graph up 3, 1, 2, 3. Okay, and then with a slope of 1, so up 1 over 1, up 1 over 1, up 1 over 1. This is a solid line. So you're going to draw that line in. Okay, and if y is less than or equal to x plus 3, if I plug in 0, 0, 0 plus 3, and 0 here, 0 is less than or equal to 3. So we're going to shade on the 0, 0 side, which is down here, where we would hit 0, 0. Okay, and then this red line, my vertex, is the opposite of what it looks like here. So a positive 2, same as what it looks like here. So 2, 1 is my vertex, and my slope is 1. Okay, so up 1 over 1 on both directions. Okay, notice there is no bar here, so this is a dotted line. And then if we plug in 0, 0, 0 is greater than the absolute value of 0 minus 2 plus 1. So 0 is greater than, this would be 2 plus 1, or 3, which is not true. So we're going to shade away from 0, 0 here, which means we're going to shade up here, right? Because 0, 0 is down here. That's false. So we're going to shade away from it, shade the opposite side. And what you notice is the overlap happens right here. So that is your solution. Okay, lots of graphing again today. Have fun with that.